Good morning, good afternoon. This is 6.5, page 354, and I will continue multiplying polynomials. So question number 9. So the method I'd like to use here is the distributive property. And so how that works is you, again, take the first term in the binomial and multiply it by the first, second, and third term in the second polynomial. So we'll take x multiplied by x squared. And again, I'm going to show all my work. I'm also going to write it down in this box area. So it would equal x times x squared, x multiplied by xy. So we're going to add. Plus x multiplied by y squared. Okay, now plus second half. Your second term in the binomial multiplied by every term in the polynomial. So that would be 2y multiplied by x squared plus 2y multiplied by xy plus 2y multiplied by y squared. And so x times x squared is the third, times x squared y. Cannot multiply these, different bases. xy squared, 2yx squared, y squared x, this becomes 2y to the third. Combine like terms. So x squared y, x squared y. These are like terms. And also xy squared and xy squared. And so I will combine those. The third, x squared y plus 2x squared y is 3x squared y. And now I'll arrange the variables in order. So it's 3. I'll start with the x squared term. X squared factor, that is y. Okay? So you can do that. You can switch your x and y variables since you're multiplying. That's called the commutative property. Plus, okay, here, xy squared plus 2y squared x. Same thing if you switch the x and y variables. So that would be 3y squared x. And finally, plus 2y to the third. You also notice that oftentimes when I combine like terms, I cross off the terms that I combined so that I keep track of what I've just done. So if it's helpful when I combine these two terms, you might want to cross those off so that you don't get distracted and lose the other like terms that you're combining. And then, of course, also here, once those are combined. And you bring down what's remaining. That becomes your answer, the product of the two polynomials being multiplied. Okay, so here's the next question. And the next question is related to a quadratic in vertex form. So let's read the question. It says the vertex form of a quadratic function f of x equals a times the quantity x minus h squared plus k. Use your knowledge of multiplying binomials to complete the following. Now, you may have never seen this form. What this does is when we talk about the vertex, we talk about the point on a parabola that represents either the highest maximum point or the minimum lowest point on the parabola. And I'll give you an example of that. So let me highlight these letters H and K. So if I was to graph a parabola, this is just a sketch, it would look like that, right? And so this point here would be your vertex, and that would be your minimum point, and the coordinates of the vertex would be, we know they're called x and y, right, the xy coordinate, but in this form, the values of x and y are found by looking at these numbers called h and k. And so those variables h and k are numbers that represent the x and y coordinate. And so it would be h and k. Those would be your values for the variables x and y that represent the vertex. Okay, so the coordinates of the vertex are h and k, found in this quadratic function. Now with that said, I want us to use what we know about multiplying binomials to just rewrite this expression. So we have this x minus h squared, and recall that the x minus h squared, the quantity, would just be x minus h times the quantity x minus h, right? Because of the second power. And so that's what goes here. And we wrote this first portion by expanding the expression. Okay? And of course, once you get to this place here, now they use the distributive property to multiply through and come up with a with the next expression. And that's what they're saying here. They're saying multiply the binomials, and these are your two binomials. Okay? So let's do that. So x times x is x squared. X times h is xh. H times x is xh. And h times h is h squared. So what we end up with is this, x squared. Now I'm going to do this in my head here. X, well, I'll show the step. It would be negative hx. This is also the inner term, negative hx. And positive h squared, a negative times negative. Continue. Be x squared minus 2hx plus h squared. Okay? And so those are the values that go here. See, x squared minus 2h plus h squared. Okay. Then it says to distribute the constant a. And so if you were to multiply through by a, here, you end up with a 2hx. Well, it should be written this way. 2 a h, and this should be written as a h squared. Okay. Plus k. All right. Now, barring any mistakes, let's answer the next portion of this question here. Compare this rewritten form to the standard form of a quadratic function. F of x equals ax squared plus bx plus c. Discuss how b and c relate to the rewritten question, or function. How can you rewrite this quadratic function in vertex form so that it is in standard form? So let's compare these, okay? So if I were to look at this form here versus this form, comparing them, what I notice is that my A value, of course, is in the same position, but the B value here in the standard form would be this value here, with the negative sign included, okay? And then the C value in the standard form correspond to this value. Okay, so there's a more specific relationship between how B and C are related to the standard form of a quadratic function when being compared to this new form. Just had a phone call, had to answer. So after distributing and rewriting the vertex form into a standard form, you see that B is related by this expression and C is related by this expression, okay? So the last portion says, how can you rewrite a quadratic function in vertex form so that it is in standard form? And how? Well, you take the vertex form and you multiply the squared term, which is here. Multiply those binomials and distribute the constant A, and that is how you do it. So be your steps right here. So you have your vertex form. Actually, vertex form will be up here. Right? You expand it. It's a product of two binomials. Expand the power. Use the FOIL method to multiply the binomials or distribute. That'll be step 3. And distribute the constant A. And this becomes the rewritten form of the vertex form function, quadratic function, rewritten in standard form. Okay? And we now know that the value of A in this new form remains the same. The value of B is related by this expression, negative 2AH, and the value of C is related by this expression, AH squared plus K. Hey, thanks for watching. Hope it helped. And remember, study hard and learn a lot.